All right, so investigating a constant rate of change. The U.S. Department of Agriculture defines heavy rain as rain that falls at a rate of 1.5 centimeters per hour. Okay? Now, whenever we see something per something, that's kind of a constant rate of change. That means that the rate does not change, right? So constant means unchanging change. Okay? The table shows the amount of rain that falls in various amounts of time during a heavy rain. Please complete the table. So if I increase, because it says 1.5 meters per hour, we know that that's the slope, right? So the slope is 1.5. And they tell us that it goes through the origin because they give us at 0, and if you think about it, at 0 hours, at the very beginning of when they start tracking the rain, the rain has fallen 0 inches, right? Or centimeters in this case. So because it goes through the origin, we know that the equation for this is y equals 1.5 times x, right? And so, well, that's not the best drawn x. So this is like x and this is like y, okay? So when I increase by 1, it makes sense that I'm going to get 1.5. In other words, I'm going to say 1.5 times the x value of 1 is equal to 1 times 1.5. Now, to get the number that goes in here, and by the way, we are adding 1.5 every time we add 1. To get this one, I'm going to say 1.5 times 2. And if you don't know what that is, hopefully you guys have calculators. If not, you can grab one. I'll put it over here to the side quietly. Grab one. Just grab one. I'm going to say 1.5 times 2, and that's 3. So this comes in here as 3. And when you have to do a lot of these, in other words, for the next one, I would say 1.5 times 3. That would give me 1.5 times 3. That would give me 4.5. And I want to show you a neat little trick. You could do this too. If I know the equation of the line, which we're guessing that it's y equals 1.5 times x, I can actually put that in the calculator. So go to y equals. There's going to be a bunch of equations there. Hit clear. Clear them all out. Remember, the y equals button is this button right here. All right. So then, once you've cleared everything out, what I want you to do is just put 1.5 times x, or just put x. Now, I can get the table of values by hitting second and then the graph button, and then I get this. These are the values for this equation. So when x equals 4, what's the y value? Well, I just look here. When x equals 4, y equals what? You can talk now. Oh, now you're quiet? Talk. When x equals 4, y equals, yes, 6. Okay? So y equals 6. When x equals 5, 7.5. Very good. Okay, so now we got to continue. It says, plot the ordered pairs on the graph. So also remember that this is the point 1, 1.5. This is the point 2, 3. We're going to plot the point 0, 0, right? Because these are the x, y's. My tablet is being goofy today. And then when x equals 3, y equals 4.5. So all I'm doing is the points, this is the x, this is the y. So I'm going to do 0, 0, right? Then when x equals 1, I'm going to go up about 1.5, which is about right here. When x equals 2, I'm going to go up to 3, which is right here. when x equals 3, y equals 4.5, which is about right here. And then when x equals 4, y equals 6, which is this point right here. When x equals 5, this is 5, I'm going to go up to 7.5, which is about right here. Then that's it. That's all they want me to do is just graph the points like that. Okay? Now it says, how much will it be when it's 3.5 hours? Well, what I need to do is say 1.5, and then put in my x, which is technically the x value are the hours. So they said 3.5 hours, so I'm going to plug in 3.5. Now that I'm just going to use my calculator for, so I'm going to hit second quit, and I'm going to say 1.5 times 3.5. That gives me 5.25. 5.25 what, guys? Centimeters, right? Because we're measuring the rain, and the depth of the rain is in centimeters. It says plot the corresponding points at 3.5. So here's 3, here's 4. 3.5 is going to be 5.25, which, by the way, is like right in the middle, right? So then it says, what do you notice about all the points that you've plotted? What do you guys notice?
It goes in a constant line.
Yeah, it's a straight line. I'm going to say straight line. That's a little redundant too. Whenever we say something's a line, technically in math, it's straight. Anything that has a curve to it, we don't call a line, we call it a curve in a math class. Okay? But even Mr. Adams messes that up sometimes. I make the mistake. So it says, is the total amount of rain that falls a function of the number of hours? Why or why not? The answer is yes. Why? Well, there's lots of things you could say. You could say the points pass the vertical line test. Points pass vertical line test. Now, what does that mean? Passes the vertical line test. Well, the vertical line test doesn't tell us it's a straight line. We could see it's a straight line. We don't need to test. But the vertical line, remember that the vertical line test says that if I draw a vertical line anywhere on this, I'm only going to cross the graph once. So if I draw a vertical line here, I'm going to cross once. If I draw a vertical line here, I cross once, cross once, cross once, cross once. So that says that it's a function. But really, what we're looking at graphically, what we're determining is that there are no repeat what? X's. Because if the X's were to repeat, then you'd have two dots. In other words, it would cross more than once that vertical line. So the reflection then for this is, suppose you continue to plot the points for times between those in the table, 1.2 hours, 4.5 hours. What would you say about these locations?
It will be in between the other points.
Yeah, or you could say they would be on the line, right? So if I were to connect the dots, those points would fall on this line. Does that make sense?
Yep.
Okay. I'll leave that up there so you guys can finish